First, we dive into behavioral biometrics, a key background element of signature recognition. Now, what exactly are behavioral biometrics? Well, they are a unique form of biometrics that focus on the measurement of individual human behavior. This fascinating field involves studying and analyzing the unique ways in which individuals behave, from the way they walk, talk, type, or even sign their name. Behavioral biometrics is especially relevant in the realm of user authentication. This is the process of verifying the identity of a user by comparing certain unique aspects of their behavior against a stored profile. It's like a digital handshake that ensures the person interacting with a system is indeed who they claim to be. What makes behavioral biometrics so crucial for user authentication? Well, it's all about uniqueness. Every individual has a unique behavioral pattern that can't be replicated perfectly by anyone else. For instance, think about how you sign your name. The speed, pressure, and rhythm with which you move your pen are unique to you. This makes it incredibly difficult for imposters to mimic your signature accurately. But it's not just about signatures. Behavioral biometrics can also involve keystroke dynamics, voice recognition, and even gait analysis. These are all unique aspects of our behavior that can be measured and used to authenticate our identity. This use of behavioral biometrics is becoming more prevalent in our digital world, particularly in areas like banking, healthcare, and online security. It's a powerful tool that can help prevent identity theft and unauthorized access to sensitive information. But like any technology, it's not flawless. It requires sophisticated algorithms and a deep understanding of human behavior to be effective. And of course, privacy concerns are always a factor when dealing with personal data. However, despite the challenges, the potential of behavioral biometrics in user authentication is vast. It's a rapidly evolving field, and we are only just beginning to scratch the surface of what it can do. Behavioral biometrics forms the bedrock of signature recognition, providing a reliable and unique way to verify user identity. And with that, we're ready to dive deeper into the specifics of signature recognition in the next scene. Stay tuned. Now let's delve into the role of touch in user authentication. Touch, as a form of behavioral biometrics, plays a pivotal role in signature-based user authentication. It's akin to the unique brushstrokes of an artist, each carrying their own distinct style and rhythm which can't be replicated precisely by another. When it comes to authentication, these brushstrokes are the dynamics of your touch. They include factors such as pressure, speed, and rhythm. Each individual's touch dynamics are unique, much like our fingerprints or retinas, and this uniqueness is harnessed in signature-based user authentication. To paint a clearer picture, consider how you interact with your smartphone. You might be a fast swiper or a slow tapper, you might apply more pressure on the screen when you're stressed, or perhaps your rhythm changes when you're multitasking. These subtleties, though might seem trivial, are unique characteristics of your touch dynamics. In signature-based user authentication, these touch dynamics are captured and analyzed. The pressure you apply, the speed of your interaction, and your unique rhythm are all taken into account to create a signature that's unique to you. This signature then becomes your key to access your device. But what makes this method reliable and secure? Well, it's the fact that replicating one's touch dynamics is a daunting task. Even if someone knows your password or PIN, mimicking your unique touch dynamics is near impossible. The way you swipe, tap, or type, your rhythm, your speed, all these factors come into play and add layers of security that are not easy to breach. So, this is the magic of touch in user authentication. It's a subtle yet powerful tool that adds an extra layer of security to your devices. And the best part, it's all happening in the background without you having to lift a finger. The uniqueness of each individual's touch dynamics is what makes signature-based authentication a secure and reliable method. Moving forward, we explore the process of feature computation and classifier training. This is where the rubber meets the road in signature-based user authentication for smartphones. Feature computation is the process of quantifying the unique characteristics of a user's touch. Think of it as the fingerprinting phase of user authentication. Just as no two human fingerprints are alike, no two touches on a smartphone screen are exactly the same. Each user has a unique way of interacting with their device. This uniqueness is captured and quantified through feature computation. But how does this process work? Well, it begins with the collection of raw data from the device's touchscreen. This data includes the pressure exerted, the speed of the swipe, the angle of touch, and so on. These raw data points are then processed and transformed into a set of features, a numerical representation of the user's unique touch signature. Now imagine having a collection of these unique touch signatures. How do you teach a system to recognize and authenticate these signatures accurately? This is where classifier training comes into play. Classifier training is a type of machine learning. It's the process of teaching the system to differentiate between different touch signatures and to accurately identify the user based on their unique signature. To train the classifier, we use a set of known touch signatures, referred to as the training set. The classifier learns from this training set, creating a model that can recognize and authenticate user signatures. This model is then tested using a separate set of touch signatures known as the test set to ensure its accuracy. The beauty of classifier training is that it allows the system to learn and adapt. As the user's touch signature evolves over time, the system can be retrained, ensuring that it remains accurate and reliable. This is crucial in user authentication, where the goal is not just to identify the user, but to do so with a high degree of accuracy and reliability. In summary, feature computation and classifier training are the heart and soul of signature-based user authentication. Feature computation quantifies the unique characteristics of a user's touch, transforming raw data into a set of features that represent the user's unique touch signature. Classifier training, on the other hand, teaches the system to recognize and authenticate these unique signatures. Through feature computation and classifier training, the system is equipped to accurately recognize and authenticate user signatures. And that, dear listeners, is how your smartphone knows it's really you swiping that screen. We have journeyed through the fascinating world of signature-based user authentication. As we navigated through the labyrinth of knowledge, we've seen how behavioral biometrics forms the cornerstone of this authentication method. It's the subtle, unique ways in which we interact with our devices that make us distinct. From the way we hold our smartphones to the rhythm of our keystrokes, every action paints a vivid picture of our identity. These behavioral biometrics are the key to unlocking a secure, personalized digital experience. The basics of touch have also been a significant part of our exploration. Our touch is as unique as our signatures, and when applied to user authentication, it offers an unparalleled level of security. As we've seen, the pressure, speed, and direction of our touch, among other factors, all contribute to a unique touch signature. By recognizing and validating this signature, smartphones can offer a robust and intuitive method of user authentication. We've also delved into the complex but intriguing world of feature computation and classifier training. We learned how the raw data from our touch is processed into meaningful features, which are then used to train classifiers. These classifiers, in turn, become adept at distinguishing between authentic and fraudulent user interactions. This intricate process is what makes signature-based user authentication so reliable and effective. In conclusion, signature-based user authentication isn't just about recognizing a pattern of strokes on a touchscreen, it's about understanding the unique behavioral traits and touch patterns of a user, processing this information through feature computation, and training a classifier to accurately authenticate the user. It's a brilliant amalgamation of biometrics, touch dynamics, and machine learning, all working together to ensure the security of our digital identities. Thank you for joining us on this journey. Don't forget to like, share, and subscribe to our channel for more enlightening content.